After viewing this tutorial, you should be able to answer 4 questions. What is a relation? What is a function? What is not a function? And how are functions represented in math? So I'll go through each of these questions one at a time, and then there'll be a short homework assignment at the end. So the first question is, what is a relation? Well, I always encourage my students to think about what the words mean outside of a math class. So when you hear relation, what do you think of? Well, whatever you're thinking of, it probably involves at least 2 things, because there has to be a relationship between them. You can't really talk meaningfully about a relation if there aren't things that are related. So in mathematics, a relation is any set of paired data. Usually, of course, we'll be looking at things that involve numbers. So here's some examples. You could look at the relation of person to their birth weight. Each person weighed something when they were born. You could look at height of a person, weight of a person. So you could take a room full of people and make paired data out of each person's height and their weight. An auto company might look at the relation of year to auto sales. So in a certain year, how many sales were there? And then, of course, the typical math teacher's example would be hours spent studying for a test and the grade that was earned. So I could look at all of the students in a class, say one person spent 1 hour studying, they got a certain grade. Someone else spent 3 hours studying, maybe they got a different grade. Certainly a math teacher's example. Okay, so what is a function? Well, a function is a special type of relation where the paired data involve what we call an independent variable and a dependent variable. Usually the independent variable is x and the dependent variable is y. Alright, what does that mean? Well, that means the value of the dependent variable somehow depends upon the value of the independent variable. So that means that for any value of the independent variable, there is one and exactly one associated value of the dependent variable. Okay, that's a lot of words. We probably should look at an example to make that more clear. Okay, so here it is in perhaps simpler terminology. For every x value, there is only one y value. So consider this chart here. We have a list of numbers. I'm going to call them my x values, or my independent variables, called the domain. And then over here I have some other values. These are going to be my dependent values, or the range. And I'm going to represent a function. So maybe 3 pairs with 7. When your independent variable, or x, is 3, the associated y value is 7. And maybe 4 is associated with 8, 5 with 9, 6 with 10, and then maybe 10 is also paired with 10. Okay, that's fine. It's fine for the x value to repeat. 6 goes with 10 and 10 goes with 10. That's fine. It's still a function, because each x value has only one y value. You don't see a certain number over here being linked up with 2 different numbers over here. Okay. It's often helpful to think about what's not a function. So suppose I had the same x values and y values, or domain, supposedly domain and range, and then suppose 3 was paired with 7, and 4 was paired with 8, and 4 was also paired with 9, 5 with 10, 6 with 10, and 10 with 10. Okay, it's not a problem that 5, 6, and 10 all point to 10. That doesn't make it not a function. The problem is right here. 4, one of your supposedly independent variables, is being linked with 8 and also 9. So that's not a function. It's a relation, but it's not a function. Okay, here's some other examples. If you did the relation of person and their phone number, that's not a function, because one person might have more than one phone number. For example, my roommate, she's got a home phone and a cell phone. So that's not a function. All right, height, weight, that's not a function. Two people could have the same height and a different weight. All right, now perhaps a little more mysterious is this equation, x squared equals y. The reason this is not a function is, imagine that x is 3. Well then, no, that's not a good example. Let's back up. Suppose that instead x is, oh, you know what? This isn't right. Let's cross this out. I meant to write, sorry about that, y squared equals x. All right, so now suppose y is 3. If you square that, you'll get x, or 9. Okay, now think about this. Suppose y is negative 3. If you square that, you also get 9. So if you look now at these two ordered pairs, the x value is repeated. 9 is being paired with 3. 9 is also being paired with negative 3, and that's not a function. Sorry about this. That was a mistake on my part. Here you can see a graph of y squared equals x. So for example, right here is the point 9, 3. Here's the point 9, negative 3. We often look at a graph and use what we call the vertical line test to determine if it's a function. This graph is not a function because see this vertical line crosses the graph more than once, which means this x value has two different y values. So anytime you can touch the graph more than once with the vertical line, it's not a function. Okay, how are functions represented in math? Well, they can be represented with a graph. That's what I showed you on the previous screen, although that one wasn't a function. They can also be shown as a table. So here you have a table. This is the function, I just made it up, that pairs odd numbers with 0 and even numbers with 1. So that's a function because each input, or x value, only has one output. All right, so that's tabular format. We'll also spend a lot of time looking at representing functions with an equation or analytically. So we'll write y equals f of x. And what that means is y depends on x. You apply some rule, usually to x, to figure out what y is. Now, practically speaking, if it's in this form, it's more useful. This tells us what to do to x to get y. If you want y, plug x in to this rule. Please be aware that when we write this, f of x, it doesn't mean multiply. It means apply some rule, f, to the variable x. All right, so here's how that works if you actually are plugging some numbers in. So if I wanted to know f of, say, 5, well, I plug 5 in for x. 3 times 5 minus 7, or 15 minus 7, which is 8. You could also find f of, let's say, 20. Well, you plug in the 20 for x, so 3 times 20 minus 7, or 60 minus 7, or 53. You could also plug in a negative number, f of negative 2. Well, 3 times negative 2 minus 7, or negative 6 minus 7, or negative 13. You could even plug in a fraction, f of 3/4. Well, 3 times 3/4 minus 7, or 9/4 minus 7, or 9/4 minus 28/4, or 9 minus 28. 28 minus 9 is 19, but this is the reverse order, so negative 19/4. Okay, I did that kind of fast. Hope I didn't make a mistake. For your homework, here's what I want you to do. Explain in your own words what a function is, and in your explanation include the words domain and range. Number 2, look at this graph right here and explain how you know from looking in the graph that it's not a function. Then for number 3, I want you to plug in these numbers 0, 1, and -1, 2, -2, and 0.6 to this rule. Remember to follow PEMDAS. Square your number first, then multiply it by 3, then add 5. Okay, that was a long video. See you tomorrow.